Good morning, good afternoon, good evening, ladies and gentlemen, and in today's video we're going to be looking at periodic functions. Now, a periodic function is basically like a function that has a repetition. So basically it repeats itself. And the best way to see that is, for instance, in this example here, you can see that it's increasing, then it's decreasing, then it's increasing, and so on and so forth. So what am I noticing? Well, it increases, then it decreases. Increases, then it decreases. Increases, then it decreases. So it increases, decreases. This is the pattern that's here. So every time it repeats itself, this is called a cycle. Okay, so you can see here how many cycles would I have in this example? Well, it increases, decreases, and it's increasing again. Whoop, nope, stop right there. So this is one pattern. Alright, so then it's increasing, then it's decreasing. Okay, stop. That's another cycle. Increasing, then decreasing. Oh, stop. That's another cycle. So there's 3 cycles here. Next, there comes what they call a period. Now, the period is basically the length of one cycle. So, how long does it take to finish one cycle? Well, you can see here it goes increasing, decreasing. So this is one cycle. How long did that take? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now keep in mind, this one, if we're going to go by this pattern here of increasing, decreasing, this is an incomplete pattern. You could probably extend it. Extend it to what? What am I noticing? Each time I have this negative minimum point, well, this happens at 2, this happens at 7, this happens at 12. This doesn't really seem to make a pattern, does it? So let's see. Let's see if we can trace this. So every time it starts 5 points later. So 1, 2, 3, if you're including this, 1, 2, 3, 4, 5. 5 points later. So it hasn't really started yet, because this is really only 4 points. One, if you count 1, 2, 3, 4. So I would have had to extend it. So if I were to extend this, let's do that. Bear with me here with my horrible drawing. So this would be the true minimum. Okay. So if I did that, what do I got? Well, 1, 2, 3, 4, 5. So that's definitely 5 points in between. So that is definitely my period. My period is 5. So that brings us to what they call the axis of the curve. Another name is called the midline. Which we can get using this formula, y is equal to max plus min divided by 2. Essentially, you're getting your average. My maximum is 4. My minimum is minus 2. So 4 plus minus 2 divided by 2, well, that's going to give me 1. What does that mean? That means that at 1, you'll notice that you always have the increases and decreases. You can see increase, decrease. We're basically cutting my cycle in half. So when we talk about the height here, this has another name as well. It's called the amplitude. It also has a formula. Max minus min divided by 2. So that's 4 minus 2 divided by 2, which is 3. What does that basically tell me? That tells me that where my axis is, if you count 3 up, you'll get your max. 1, 2, 3. If you count 3 down, you'll get your min. 1, 2, 3. So that's my amplitude. So, in this case here, let's try to do some guessing. Okay, so what have I told you f of 12? Well, you don't need to guess because you can see it here in the graph. F of 12 is minus 2. But see, even if I did not know it was minus 2, I'd be able to figure it out. So how would I have been able to figure out if I didn't see it? Well, I can always just extend it. But let's see. Let's see what we can guess here. Okay? So if this here is my 12, and I'm saying it's going to be negative 2, how can I guess that without actually drawing it? So let's take a look at our graph. Let's take a look at our pattern. So 12, well, that's just a multiple of 3. It's also a multiple of 4. But how does that really help me? Let's take a look. Each time I have a maximum, it happens at, well, 0, 5, 10. So my maximums happen in multiples of 5. When do my minimums happen? Well, my minimums happen every 5 points as well. So 1, 2, 3, 4, 5, every 5 points. So it started at negative 3, then it went to 7. Well, 2 plus 5 is 7. 7 plus 5 is 12. So that would be my next minimum. And so on and so forth. So basically, you add your period to your last point. So what have I told you now? F at negative 4. Well, f at negative 4, where would that get me? So I told you every single time you're going by 5s. So how would I figure out something that's just a point behind me? And to figure that out, again, you're going to have to look at your graph. And if you look at my graph, what happens? Right after the minimum each time, it ends up going up to 1. Because you can see, at 2 is my minimum. At 3, it's at 1. So, well, 2 points later, that is. So 2 points later, it's always at 1. So, if at negative 2, it's at 0, then at negative 4, I should be at 1. What about f of 35? Well, f of 35 is basically the same thing as saying f of 5 because this is a multiple of 5, which is where I find my maximums. So this should be 4. What about f of 71? Well, f of 71 is the same thing as saying f of 1, because remember, this is my multiples of 10 there. 10, 20, 30, 40, 50, 60, which leaves me with 1. Well, f of 1 is just 1. And that's how you'd interpret this data here. So let's read this example here. So a Ferris wheel has a diameter of 60 meters and stands 5 meters above the ground. As it rotates, the height of a particular seat above the ground is changing. It takes 1 minute for the Ferris wheel to make 1 complete revolution. Pick a seat and graph its height as a function of time. So the best way to do this type of example is, once again, you're going to have to underline some key words here. Okay? Now, it says what? You're 5 meters above the ground. You start 5 meters above the ground. Okay? And of course, you have a diameter of 60 meters. This is important. As it rotates, it's changing. It takes 1 minute for the Ferris wheel to make 1 complete revolution. Okay? So let's actually make an XY chart here. It's actually pretty easy to make an XY chart for this. Alright, so our XY, you're going to have time and height. So let's say in 0 minutes, how high above the ground am I? Well, how high am I above the ground? I'm 5 meters above the ground. Why? Because we start 5 meters above the ground. Now, how do I know how much to go up? Well, it says it takes 1 minute for the Ferris wheel to make a complete revolution, which means maximum you want here is 1 minute. So how can I do this? Well, you can do it however you wish to do it, but I choose to do it in quarters because you want to get yourself a good representation here of your Ferris wheel. All right? So you want to go 0, 0.25, 0.5, 0.75, and then 1. Okay? So after 0.25 minutes, which is basically 25 seconds, how far up have I gone? Well, I would have gone up 35 meters. Now, how do you know I've gone up 35 meters? Well, you know it has a maximum of 60 meters. Maximum 60 meters. And you know it's done 1 complete rotation in 1 minute. So that means in 1 minute I should be back at the 5 meter mark. Which means halfway up I should be at my maximum. So halfway up after about 0.5 minutes I should be at 65 meters. Not 60, because remember you start 5 meters above the ground. Which means this would be 35. And then this would be 35. Because remember, this is making yourself a nice parabolic curve. Okay? So, how would I graph this? Let's see. Let's make our graph. Alright, so we're going to go, let's go 1 between each one, so 0.25, 0.5, 0.75, 1. Okay, let's stick with that. And let's go in 30s, I guess. 30, 60, nope, let's go 40s. Yeah, let's go by, let's go by 10s. Yeah, that works. We'll go by 10s. We're gonna go by 10s here. So, 40, 50, 60, 70, and so on. So I know I'm going to start at 5. 5 is going to be about here. You don't have to be ultra specific here. 0.25, I'm going to be at 35, which is going to be a little bit higher than this. Oops, not there, right here. Okay, and then we're going to be at 65. Going to be a little bit taller than this, yep. And 0.75, we're going to be right back over here. And then we're going to be back at 5. To connect them all, my very, very nice parabola curve there. And that's it. What do you notice? Well, it's a parabola. It's basically symmetrical. And that's it. Now, you're going to wonder, how did you get all of this stuff? I mean, where are you getting the 35? Where are you getting the 65? Where are you getting the 35? Like, oh my God, Mr. E, what's happening here? This is where our formulas come in. Remember, it takes 1 whole minute to go through a cycle. So if it takes 1 minute to go through a cycle, how can I figure out what my intervals are? So this is where the amplitude and the cycle comes in. So remember, the formulas we got, max plus min divided by 2. What's my max? My max is what? Well, I know the diameter of my wheel is 60, so that's my max completely. Divided by 2, which is 30. So you know I'm going by 30s here, by these increment of 30s. Okay? So, I'm going by 30s. And then my amplitude, well, my amplitude, remember, is my maximum, 65, minus my min, divided by 2. That's just going to give me 65 minus 5 divided by 2, which is going to give me 30. Okay, so, and that's where you're going to be getting your amplitude and your other stuff here. There's not much else we can say here when it comes to periodic functions. Like, periodic functions, the best way you can do them, honestly, is just figure out what your amplitudes are, figure out how long of a length you're going to get to, and you just go from there. Hope you have understood all of this, and have yourself a great day.